Good morning, students. Today's topic is limiting reagent. This is the last topic, and this is very important topic and very simple topic. Here the definition is the amount of reactant which is completely converted into product is called limiting reagent. That means this limiting reagent is present in reactant side in a given reaction. It is not present in product side. I repeat once again. This limiting reagent is present in reactants side in a chemical reaction. It is not present in products side. That is the first point. Second point, what is the definition? The amount of reactant which is completely converted into product is called limiting reagent. What we think every time in a given chemical reaction, all amount of reactants are converted into products. We think like that, but actually that is not correct. Because in some reactions, not in all reactions, in some reactions, not all amount of reactants converted into products. Very few, some amount of reactants only converted into products. Some amount of reactants will be remain after completing the reaction. So you have to know that point. So in every reaction, reactants, not in every reaction, in some reactions, all amount of reactants is not converted into products. Some amount of the reactants will be left after completing the reaction. So the amount of reactant which is completely converted into product is called limiting reagent. That is the definition. Next, second point, the amount of product depends on limiting reagent. That means the amount of the product in a given reaction depends on limiting reagent. If I say the example, if we discuss the example, then you will get clear idea about this one. For example, take this reaction 2H2 plus O2 gives rise to 2H2O. In this reaction, H2 and O2 are reactants and H2O is the product. We know that very well. Suppose as per reaction, what is the amount of H2O? Hydrogen. How many hydrogens here? 4. Each hydrogen 1 atomic weight. Amount of hydrogen is 4 grams. And what is the amount of oxygen? Each oxygen 16. 2 oxygens 32. Water 16. 2 waters means 36. This is the amount as per reaction. For example, if amount of H2 is 2 grams and amount of O2 is 8 grams. If amount of H2 is 2 grams and amount of O2 is 8 grams, then how much amount of water? That is this is the given condition. Then how much amount of water? For in such cases, you have to find limiting reagent. You should not sum 2 plus 8 totally 10 grams. You should not think like that in such cases. So in this type of cases, we have to find limiting reagent. How to find limiting reagent? While finding the limiting reagent, first you should forget about product amount. First you should forget about product. What I told you, limiting reagent is present in reactant side. So no need to bother about product amount sometime. So we have to find limiting reagent. That means whether H2 or O2, which is limiting reagent. So while finding limiting reagent, we have to think like this. First, remove product amount. Next, see, as per reaction for 4 grams of H2, 32 grams of oxygen required. Then for 2 grams of H2, how much amount of oxygen required? We have to calculate like that. For 4 grams of H2, 32 grams of oxygen is required. Then 2 grams of H2, for suppose 2 grams of H2, how much amount of oxygen required? That means you have to find this amount. Actually this is given condition. We are finding required amount. For 4 grams of H2, 32 grams of oxygen required. For 2 grams of hydrogen, how much amount of oxygen required? That means what is the calculation? 2 into 32 by 4. 2 into 32. See. 2 into 32 by 4. That means 2 to 16. So total value how much? 16. 16 is what? Here 16 is the amount of oxygen, but here given amount is how much? 8 grams. Here this is required amount. Requirement is how much? 16. But this value, this oxygen is this given amount is less than required amount. So automatically this given amount is less than required amount. Automatically this will be limiting reagent. If given amount is less than required amount, automatically that will be limiting reagent. So in this reaction O2 is the limiting reagent. If O2 is the limiting reagent, automatically this H2 will be excess reagent. This H2 will be excess reagent. Or by calculating the value of H2, then also we get idea about excess reagent. For example, see, for 32 grams of oxygen, 4 grams of H2 is required. Then for 8 grams of oxygen, how much amount of hydrogen? See, what is the calculation? 8 into 4, that means 32 by 32. 32 by 32, how much? 1. That means theoretically 1 gram of hydrogen is required for 8 grams oxygen. But here 2 grams is the given amount. This is given amount. So here given amount is more than required amount. Here given amount is more than required amount. So automatically that part will be excess reagent. If given amount is less than required amount, that will be limiting reagent. This is important point. If given amount is more than required amount, that will be excess reagent. So we found limiting reagent. So what is the limiting reagent in this reaction? Oxygen. Oxygen is the limiting reagent. Then we can calculate amount of water. How? By calculating product amount, you just forget about H2 amount, because that is excess reagent. What I told you here, the amount of product depends on limiting reagent. So that for 32 grams of oxygen, 36 grams water required. Then for 8 grams of oxygen, how much amount of water required? See, so question mark comes this side. So what is the calculation? 8 into 36 by 32. 8 into 36 by 32. Then finally 9 grams of water. So that is the way to calculate limiting reagent in this model. By using, after finding the limiting reagent, then only we can find the product amount. So in this reaction, why it is called limiting reagent oxygen? Because in this reaction the total amount of oxygen is to be reacted. But in this reaction, among 2 grams, in this 2 grams of hydrogen, only 1 gram of hydrogen reacted, because already we found how much amount of oxygen is required. So theoretically 1 gram of oxygen required. That means here 2 grams of hydrogen is there. That means hydrogen amount is more than required. That is why this is excess reagent. That means not all amount of hydrogen is reacted. Only 1 gram of hydrogen is reacted. The remaining 1 gram of hydrogen is to be left. That means that will be remained after completing the reaction. But in this case 8 grams of oxygen is completely reacted. That is why it is considered as limiting reagent. What is the definition? The amount of reactant which is completely converted into product is called limiting reagent. Next, one more example. If we discuss one more example, you will get clear idea. See, suppose the question is, when 6 grams of nitrogen reacts with 2 grams of hydrogen, when 6 grams of nitrogen reacts with 2 grams of hydrogen, then calculate amount of ammonia. So here weights are given regarding nitrogen and hydrogen. When nitrogen and hydrogen combines, then which will form ammonia. So for this type of model also we have to write equation. If we are unable to write the equation, then we cannot solve this type of model. First we have to write equation N2 plus 3H2 gives rise to 2NH3. That is the required equation for this question. Next, as per reaction, first we have to write the amounts as per reaction. As per reaction, what is the amount of nitrogen? 28 grams. Each nitrogen 14. 14 to 28. Next, how many hydrogens here? 6. Each hydrogen 1. 3. So 6 hydrogen, 6 into 1. Next, ammonia 17. 17 to 34. So these are the amounts as per reaction. Now we have to apply given condition. Given condition is how much amount of nitrogen? 6 grams. Next, how much amount of hydrogen? 2 grams. Then we have to find ammonia. That means when 6 grams of ammonia and 2 grams of ammonia are given, then what is the amount of, when 6 grams of nitrogen and 2 grams of hydrogen are given, what is the amount of ammonia? So what we have to find in such case? We have to find limiting reagent. That limiting reagent is always present in reactant side. While finding limiting reagent, we have to forget about products. So for 28 grams nitrogen, 6 grams of hydrogen required. Then 6 grams of nitrogen, how much amount of hydrogen required? That means, what is the calculation part? 6 into 6 by 28. 6 into, calculate the hydrogen amount theoretically. 6 into 6 by 28. How much? 36 by 28. Finally 1.28 grams. This is required amount. Here 2 grams. This is given amount. Here required amount is less than given amount. So that this will be excess reagent. Automatically the other part will be limiting reagent. So in this reaction H2 will be excess reagent and nitrogen will be limiting reagent. Or we can find nitrogen amount also. For 6 grams of hydrogen, 28 grams nitrogen required. Then for 2 grams of hydrogen, how much amount nitrogen? So what is the calculation part? 28 into 2 by 6. Calculate the nitrogen amount theoretically. 28 into 2 by 6. So 28 by 3 finally. That means what is the required amount? 9.33 grams. 9.33 grams. Actually here 6 grams. Here 9.33. This is required amount. So here required amount is more than given amount. If required amount is more than given amount, automatically that part will be limiting reagent. So that means theoretically 9.33 grams nitrogen is required. So here given amount is less than required amount, so that this nitrogen will be considered as limiting reagent. So while finding product amount, we should forget about excess reagent. So for 28 grams, 34 grams required. Then for 6 grams, how much amount required? So what is the calculation part? 6 into 34 by 28. So finally, for 28 grams of nitrogen, 34 grams of ammonia required. Then 6 grams of nitrogen, how much amount of ammonia required? So what is the calculation part? 6 into 34 by 28. So finally 7.28 grams of ammonia will be formed. That means what? In this 6 gram, in this amount nitrogen, 6 grams of nitrogen will be reacted. That means this total amount will be reacted. But in this 2 grams, how much amount reacted? 1.28 grams only reacted. The rest of 0.72 amount will be remained. 0.72 will be remained. That is why it is considered as excess reagent. So this is the model regarding limiting reagent. This is very important topic. This is the last topic. This is all about some basic concepts of chemistry. Thank you.